Hello friends, today we are going to study the advanced computer graphics in which we focus on the points spline curve and Bezier curve. The spline curve. Spline curve is a mathematical representation for which it is easy to build an interface that allow user to design and control the shape of the complex curve and surface. See, basically the spline curve is based on the control points. Okay, the spline curve is defined for modified and manipulated by control points set of coordinates position which indicates the general shape of the curve is known as the control points. The general approach of that the user enters a sequence of a point and the curve is connected. The shape closely follow the sequence. This point is known as the control point. A curve that actually processes through each control point is called as intraplotting curve. See, intraplotting curve. When the curve passes through the all control points, the resulting curve is said to be intraplotted curve. And another curve is when a curve does not necessarily passes through all the control points, then the resulting curve is said to be approximating curve. See the graphical representation of approximating curve. Once we establish the interface, then to change the shape of the curve we just move the control points. Okay, the when two control point is there, when we connected the starting point and the ending point of the ending points, then the polygon is formed. The polygon form is known as the convex hull. In other words, the polygon covering all the control points of a spline is called convex hull. It ensures that curve is never cross the convex hulls. All the control points lies within the within the convex hull. The advantages of the spline is for designing the smooth curve for in automobile industry. When we design a automobile vehicle or any type of gadget which is based in automobile industry, the spline curve is widely used for modeling smooth surface. In early ages, the carpenters also uses spline curve for smoothing of the edges or the surface. Another advantage of spline curve is for determining the animation path. In nowadays, the animation industry in the industry, on the basis of computer graphics, the animation path is designed by or on the basis of spline curve. Next curve is the Bezier curve. The Bezier curve. M. Bezier, a French mathematician who worked for a Renault motor car company, he invented his curve to allow his firm's computers to describe the shape of the car bodies and alternative spline. Bezier curve is the nothing but the alternative spline. Bezier curve is an another approach for the construction of the curve. A Bezier curve is determined by the defining polygon. Bezier curve have a number of properties that makes them highly useful and convenient for curve and surface designing. Okay, Bezier curve is a parametric curve frequently used in computer graphics and related fields. Generalization of Bezier curve to higher the dimension are called Bezier surface, of which the Bezier triangle is a special case. They are also easy to implement Therefore, Bezier curve are widely available in various CAD system and the general graphical package. In the section, we will discuss the cubic Bezier curve. Path in the Bezier curve, the path is not bound by the limits of rasterized images and are initiative to modify. Bezier curve are also used in animation as a tool to control the motion. Basic definition of the Bezier curve is defined by the order or a linear quadratic or cubic equation and a set of control point, that is p naught to pn, up to a number of undefined number, the number n of which depends on the order, n equal to 2 for linear, 3 for the quadratic, and etc. The first and the last control point are always the end point of the curve. However, the intermediate control point generally do not lie on the curve. A Bezier curve is particularly a kind of spline generated from a set of control point by forming a set of polynomial function. See in uh, linear graphical representation of the curve in which two control points are given, thus function points are computed from the coordinate of the controls. The Bezier curve is defined by the defining polygon. It has no number of properties that makes them highly useful and convenient for the curve and surface design. As we discussed earlier, it is approximate spline curve. Properties of the Bezier curve. The first and last control point are interpolated. Means every first point and last point is interpolated, which is connected to each other. Without connection of first and last point, the Bezier curve doesn't form. The tangent of the curve at the first control point is along the line joining the first and second control point. The tangent at the last control point is along the line joining the second last and last control point, as we discussed in earlier point. The curve lies entirely within the convex hull of its control point is known as it is the main property of Bezier curve. Okay. The basic function of Bezier curve is real. Bezier curve always passes through the first and last control point. The curve generally follows the shape of the defining polygon. This is another property of the Bezier curve. The curve exhibits the variation dimensioning property. This means that the curve does not oscillate about the straight line more often than the defining polygon. The Bezier curve is invariant under the affine transformation. This is the another one property of the Bezier curve. Next property, the degree of polynomial in Bezier curve is defined. The curve segment is 1 less than the number of the defining polygon point. Therefore, for 4 control point, the degree of the polynomial is 3. That is cubic polynomial. That is shown in the graphical representation 3, in which 4 points are there, but the degree of the polynomial is 3. The cubic base in the cubic Bezier curve, 4 control points are used to specify the complete curve. Unlike in B spline curve, we do not add intermediate point and smoothly extend the Bezier curve, but we pick 4 more points and construct a second curve which can be attached to their two for the first. After studying the properties, now we are on the applications of the Bezier curve. Bezier curve are used in the time domain, particularly in animation and interface design. That is, Bezier curve can be used to specify the over velocity over time of an object, such as an icon moving from a point to b point, rather than simply moving at a fixed number of pixels per step. Okay. Bezier curves are widely used in computer graphics for modeling or smoothing of curve. The quadratic and cubic Bezier curve are most common. Higher degree curve are more expensive to evaluate. When more complex shapes are needed, low order Bezier curve are patched together. These are some applications of the Bezier curve. Thank you.